Hey, what's poppin' YouTube? Code Adventurers, welcome back to the Advent of Code 2023. Chris here, and last night we braved the haunted wastelands, chasing ghosts and syncing up our cycles to conquer the puzzle. If you got tangled in the ghostly web, catch up, because tonight we're diving into day 9, and I've just brewed a fresh pot of coding inspiration. I hope that coffee is steaming, your code editor is ready, and you're geared up for another thrilling coding adventure. If you haven't joined the Code Adventurer crew yet, hit that subscribe button, give it a like. If you're fueled up and ready for tonight's challenge, ring that bell to stay in the loop of all things Advent of Code. After navigating the spooky wastelands and getting our cycles in sync, I'm buzzing with excitement to see what mystery day 9 holds for us. Grab that coffee, clear your coding space. Let's code our way through the night. Day 9 of Advent of Code. Are you ready to uncover the secrets that await us tonight? Let's code our way to another victory in 22 seconds. I'm using GPT right now to sort of create these intros. If you're interested in Bard creating the intros instead, let me know and I'll switch. Just comment below. And we can make that happen. All right, let's go. Day 9, Mirage Maintenance. You ride the camel through the sandstorm and stop where the ghost maps told you to stop. The sandstorm subsequently subsides, somehow seeing you're standing at an oasis. The camel goes to get some water and you stretch your neck. As you look up, you discover what must be yet another giant floating island. This one made of metal. That must be where the parts to fix the sand machine come from. There's even a hang glider partially buried in the sand here. Once the sun rises and heats up the sand, you might be able to use the glider in the hot air to get all the way up to the metal island. While you wait for the sun to rise, you admire the oasis hidden here in the middle of Desert Island. It must have a delicate ecosystem. You might as well take some ecological readings while you wait. Maybe you can report any environmental instabilities you find to someone so the oasis can be around for the next sandstorm-worn traveler. You pull out your handy oasis and sand instability sensor and analyze your surroundings. The oasis produces a report of many values and how they are changing over time. Each line in the report contains the history of a single value. For example, to best protect the oasis, your environmental report should include a prediction of the next value in each history. To do this, start by making a new sequence from the difference at each step of your history. If that sequence is not all zeros, repeat this process using the sequence you just generated as the input sequence. Once all the values in your latest sequence are zeros, you can extrapolate what the next value of the original history should be. So in the above data set, the first history is because value increased by 3 each step, 0, 3, 6, 9, 12, 15. The first sequence of difference that you generate will be 3, 3, 3, 3, 3. Note that this sequence has one fewer value than the input sequence because at each step it considers 2 numbers from the input. Since these values aren't all 0, repeat the process. That value differs by 0 at each step, so the next sequence is 0, 0, 0, 0. This means you have enough information to extrapolate the history. Visually, this sequence can be arranged like this. To extrapolate, start by adding a new 0 to the end of your list of zeros, because the 0 represents differences between the two values above them. This also means there is now a placeholder in every sequence above it. You can then start filling in placeholders from the bottom up. A needs to be the result of increasing 3, the value to its left, by 0. The value below it means A must be 3. Finally, you can fill in B, which needs to be the result of increasing 15. The value of its left is 18. So the next value of the first history is 18. Finding all 0 differences For the second history requires an additional sequence. Gotcha. Okay, so we're finding that, which is that, okay. And then we're finding this. Okay, and then there are no differences, so then it's all zeros. Okay. The third history requires even more sequences, but its next value can be found the same way. 3, 3, 5, 9, 15, 23. Gotcha, okay. So because we're at 0, the one above it we know is just a copy of the previous element, which is a 2. And then this indicates what the difference between this is, which is 8. And then this one indicate what this is, which is 23. And then this is what the value is, which is 68. If you find the next value for each history in this example and add them together, you get 114. Okay, let's see what our puzzle input looks like. That is a lot of puzzle input. Interesting. I am certain I can solve this eventually. Whether or not I can solve it performantly is another question. What we're going to do is there's a finite amount of calculations that we have to go through for any number of length. So in this case, you know, if we look at this input, if we look at, say, just 3 numbers, 10, 13, 22, you know that the operation is going to be a pyramid that is at most that many levels. Each number we add adds a possibility of another level. So if there are 4 numbers, we have 3 levels, etc. And so if we count the spaces in this sequence, in this selection, please, we'll just go with, well, I know there's more than one space. Come on. It doesn't matter. Anyway, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So there's 21 layers at most that we could traverse this for each number. And we don't really care so much about the values as we're processing them, in the sense that we can throw away the previous slice each iteration, and as long as we have the first value. So let's just see if we can have a memory problem, but we'll do for n in range of items. And what we're going to do is we're just going to create a slice. So while diff, or for diff, for diff, so while we have a difference, we're going to range through each one. And then we're going to create a stack, which will be a slice of int. And then, for lack of a better, at the end of each iteration, we are going to make the bucket append Okay, so that'll give us our stack, and then we can work the stack back up. So I think I want to And actually, we can just append our items to the stack. And then this is always going to be, what we're iterating on is always going to be the last item in the stack. So this will actually be stack sub length of stack -1. I think for we'll see about the memory for this, but we're going to do that. And then we're going to set diff equal false here. And then we're going to say if this will be 1, we'll say if I work sub I minus, actually, we'll do the calc. It will be work sub I -1 minus work sub I. Okay. And then we will add it to the bucket. So bucket equals to append bucket sub next. And so that will create all of our items, and we should get that pyramid shape all the way down. Yeah, we'll get rid of this. And then finally, if next not equals 0, because we have some negatives, then diff equals true. So if we find any instance where we have a difference, diff is true, so that means we need to continue to iterate down our stack. So now that we have our stacks, we have to figure out, based on this, what our next values are. So we know that once we reach all zeros, or we no longer have any diffs, we can stop at this. We're stopping at this level in all cases. So then we just need to walk back up the stack. So we get whatever that number is. We add it to the previous, add it to the previous, and then add that to the previous. Okay. So for I is the length of the stack -1, I is greater than 0, I minus. So now we're going for from the last set of items backwards. And so the value is going to be two plus this, which gives us 6, which is 8, 15, which is 23. So really, it's at this point, it's just val plus stack sub I so it's the length of that given stack -1. Missing return. Got it. Okay, okay, okay. I think I might have this backwards. So we're going from left to right here. So 3 is the number. That I think is that problem. Okay. Let's introduce these other tests now. Interesting, index out of range. Okay. Okay, so we're in a situation where okay, solvable. So if we're only going to add it to the stacks if our bucket is greater. What's going on here? That was not great time. So we've got 1 plus, oh, okay, so we're missing some value here. 4, we should have 5 here as well. 2, 3, 4, 5, right? If we look at this example, we're missing the 6 for some reason. That's one problem. Okay. And then let's look at our stack now. Okay, that looks a little bit better. So now we've got 3, 4, 5. Okay, that's fixed. Okay. All right. All right, part 1 done. Let's go into part 2. Part 2. Of course, it would be nice to have even more history included in your report. Surely it's safe to just extrapolate backwards as well, right? For each history, repeat the process of finding differences until the sequence of differences is entirely 0. Then, rather than adding a 0 to the end and filling in the next value of each previous sequence, you should instead add a 0 to the beginning of your sequence of zeros, then fill in new first values for each previous sequence. In particular, here's what the third example of history looks like when extrapolating back in time. Adding the new values on the left side of each sequence from the bottom top eventually reveals the new leftmost history value 5. Doing this for the remaining example data above results in previous values of -3 for the first history and 0 for the second history. Adding all 3 new values together produces 2. All right, well, if we go one way, we can go the other, right? I think that if we look at our input, I think we're already handling negatives. Yeah. So what I'm going to do is we'll go ahead and do a part 2 here. And let me go ahead and set up. Do I have the test cases in here? No, I didn't bring the data in for test. Let's actually do that. So we grab the initial input data. I was very focused on testing that one individual function. And let me just do this as a whole. Part 1 should have been, what, 114, I think? Yeah. So, which is what I got, so that's good. And then we'll go ahead and do part 2. When I run this, it's going to fail, but that's okay. So this is actually really straightforward and simple. All we're going to do is simply reverse. And there we go. So day 2 is just reversing the input, and or part 2 rather is just reversing the input. And if we run down here, we are done. All right, well, I spent a little bit of time spinning my wheels trying to over optimize, realizing that I was going down a terrible path based on my experience yesterday, and then just went with the actual approach of figuring out the calculations. And then once we got through part 1 rather of day 9, part 2 was a breeze. We was just reversing the string. I'll talk through the problem real quick, just in case anybody's interested. We parsed some fields. Again, thanks for the person who left the comment about the fields. That'll be handy moving forward. But let's look at the actual next val. So what we're doing here is we're just setting a diff bool, and we're using that to determine when we can break out. And we're going to always assume that there's a diff. And then we're also using a stack to maintain our stacks. And we loop through until diff is false. So on first entry, we create a new bucket. We start adding, we just define our stack for work so it's easy to reference. And then our diff is set to false, anticipating that we're going to exit. And then we work through our current stack, which by default is just the set of numbers that we sent in. That's our first stack. And we look at the next value, so whatever the difference is between those, and we put that in the bucket that we're working on. And if next is not equal 0, that means that we have a difference, or we have a diff, so we set that to true. So we're going to keep iterating through this until we no longer have a difference. If for some reason we get to a point where the buckets are not true, then meaning that we end up without a diff, then we go ahead and exit. And then finally, once we have these stacks, we walk them in reverse order, looking at the last values and just adding them to our stack, returning our final number. And that's that. And then that was part 1, so that's pretty straightforward. And then part 2, same approach. The only difference is reversing the input so that we go in the opposite direction. There was no point in rewriting our methods. That's it. You know, I fell into a classic black hole of optimizing before we know we have to optimize and not thinking through the complexity of the problem fully. But hey, we got it done. I thank you for your time, and as always, over and out.